Hello, folks. Good morning. Thank you so much for making to the session to talk about Model Context Protocol this beautiful rainy Seattle morning. How many of you know what Model Context Protocol is? Let's raise your hands. Okay, there's a few. How many people could not care less about Model Context Protocol? None. Okay, I was going to say you would be very disappointed in where this talk is going to go. Okay, so my name is Dan Delamarski. I am a principal product engineer at Microsoft, and I'm also a core maintainer of MCP. So working with our friends at Anthropic to make sure that we're actually building and evolving the protocol in a way that makes sense for the broader industry. So it's not just a Microsoft thing. Now, let's take a kind of brief detour and a bit of a history lesson. So back in the olden days, 8 months ago, we know that there's a lot of different AI tools that existed, right? Like we had Copilot, Claude existed, OpenAI with ChatGPT, Gemini, GitHub Copilot, of course. And one of the big problems with a lot of these protocols was the fact that for basically all of them, it was all just kind of an island. It is just completely kind of composed into itself, right? So if you were somebody that uses an LLM, you would use it within the context of the tool that you have, and that's kind of it. You would ask it some neat questions. If you're using it in Word, you'd ask it some Word-related questions. You use it in, ChatGPT, it'd be kind of nice. But one of the big problems that always popped up was the fact that if you start applying this in any context outside of these basic fun questions, you start running into issues. And that is, a lot of these LLMs are completely detached from the data that you have. They're completely detached from the context of your organization. They're completely detached from anything that you actually want to do. So as this problem kind of cropped up, the questions started coming up. It's like, okay, well, how do we actually solve this? What do we do about the fact that we cannot connect any of the existing data to LLMs? And like, there's several approaches you can tackle, right? You can either go and train the model on your own data and have your custom fine-tuned model, which is, it's problematic, right? It's expensive. Nobody wants to really do that. You can write layers about things like open API, which kind of exists, but then it's like, okay, great, but now you need to learn Open API and kind of try and massage a lot of the interactions into that little bubble. That's not really going to work. And also, what happens if you try to break out of this piece and kind of start thinking about like, well, what if I want to also connect to actual applications and not just APIs? So there's no really good solution on the market. So this is where Anthropic, in November 2024, came up with this thing called Model Context Protocol, right? And the easiest way to explain what Model Context Protocol is if you look at the words and you just reverse them. It's a protocol for providing context to models. That's it. That's as complex as it is, right? And like this came up and we're like, oh, great. We all know where this is going. So of course, we thought it was like, oh, we're going to unify this into one standard. And now we have 15 competing standards. Great. All this being said, MCP, I strongly believe that it's here to stay. And I'm biased here, of course, but I think it's here to stay. And the reason I say that is because the broad community is behind it. There's a lot of people and a lot of companies that are like, they're investing heavily into making sure that it is actually successful and fits core scenarios. And if you doubt this, I highly recommend going to this link. There is a talk from a good friend, Lori Voss, who's a VP of Developer Experience for Llama Index. And they talked about the fact that there's already many competing protocols for MCP. There's one from IBM, there's one from Cisco, there's one from Google, like there's a bunch of them. But a lot of the enthusiasm is kind of the community just kind of snapped to MCP. So MCP is here. I think it's going to be here to stay. And we're very excited to see where this is actually going to go. So long story longer, let's actually talk about what is MCP. I try to explain it kind of in a way that makes sense for a lot of folks and developers to click this. But at the end of the day, MCP is just a pipe. It's a pipe for your data. That's all it is. Like when you think about like, oh, there's some complex, SDKs and tooling, it's like kind of like it exists, but at its core, MCP is just a pipe for your data to go to LLM. The way Anthropic describes it is basically the USB-C for your applications and APIs to connect to LLMs. So that means that if you have a USB-C adapter to any, client, any LLM that accepts USB-C or the virtual USB-C, things will just work. It's of course an open protocol. It's all open source. And it is underpinned by JSON-RPC. So if you're not familiar with JSON-RPC, that's okay. You don't actually need to learn any of this stuff. But just so you know, it's been created by Anthropic, and it's been adopted by a lot of other folks in the industry, as I called out before. So it's not just Anthropic doing this. Microsoft is on board. We have Google that's on board. We have OpenAI that's on board. So there's a lot of support for this because it makes sense. Like people understand that they need to connect their data to LLM somehow, and this provides that interface. And the beautiful thing about MCP is that once you start snapping to the standard, you can use what you build at MCP anywhere. So whether you're building for any LLM, whether it's local or remote, like it doesn't really matter. Things just work. So let's take a peek a bit at the architecture. Like how is this thing working under the hood? So I want to start off by saying that a lot of this is underpinned by what's known as the MCP specification. Like the specification is the foundation for essentially everything that happens inside the protocol. So if you go to modelcontextprotocol.io, this is where it's only open. It's all out there with the documentation. And that specification covers basically the end-to-end of what MCP does, what the transport is, how it works, what are the SDKs, what are the security best practices, how auth works, and we'll get into that can of worms in a little bit. But this is the starting point. So there is a specification, and the way MCP works is that there is essentially think of it like if you ever worked with identity or auth, there's all these like RFCs that define how it works. MCP is the same way. Like there is a very specific way in which MCP is defined. Also, it's broken down into several components. So some of these might be familiar to you, and especially if you kind of think about like the language server protocol or like the existing client server, it's kind of the same if you really, really squint and just look at it. So there's the concept of the MCP host. This is kind of the mothership for a lot of the MCP clients. There's of course the MCP client. This is your Claude desktop, VS Code, Visual Studio, like you've seen all this stuff. And there's MCP servers that are responsible for connecting those clients to specific APIs or applications. And this is the important part here. Like what you see in this drawing here is like these are all APIs, right? You have some MCP server that talks to some API. You have an MCP server for Graph, it's going to talk to Microsoft Graph. You have an MCP server for Figma, it's going to talk to Figma. But they can also talk to applications. You have MCP servers that can talk to, I've seen some very, very creative uses where MCP servers that talk to Blender for 3D modeling. There's MCP servers that talk to Ghidra for reverse engineering. There's a whole bunch of very creative use cases where you can use MCP to not only access data, but access applications and control them. So this is kind of a really, really cool kind of detour on the sense of MCP, because people think that it's like, oh, why can't I just use OpenAPI? The standard exists. This is why, because OpenAPI is specifically tailored to APIs. This is tailored to being able to access data and context from literally any source. So with that, we have kind of three core pieces that fit into the protocol if we think about it. There is the transport layer, the data layer, and the application layer. And based on what I just described, some of this might seem kind of intuitive, but maybe not. Transport layer. Transport layer is how MCP actually communicates the data into the client and how the client interacts back with the server. There's two. There are two, and they're very much something that you probably have already heard before. So the transport layer is STDIO, which is standard input-output. It can be used for local processes. So an MCP server doesn't, like the name server does a bit of a disservice because it can actually run on your box. If you have Blender, if you have a specific application that you want to manage on your computer, you can have an MCP server that actually runs on the box without ever touching anything remote. Again, it's fast, it's simple, you can write it today with any of the existing SDKs, all this is supported. And people think that it's something like magical about this. Like, oh, this is like local MCP servers, these are these fancy like connectors. It's a local app. It's just a local app. That's all it is. Like you can write it in .NET and run it with the .NET command. Like you can run it with Python, NPX. Like it doesn't matter. It's just a local app. So when you think about even like the threat model of what am I pulling locally? Local apps. Are you going to download a local app from SourceForge or any other unknown source and just install it? No, I hope not. But it's exactly the same. Streamable HTTP is a second transport, and this is where we get into the world of remote hosted MCP servers. And these are the servers that you might have seen from PayPal and Neon and a lot of other vendors. But the idea is like they host it in the cloud, they give you a URL and then say, plug this URL into your MCP client. And there you go. It supports proper auth, of course, as it should. Things like multi-tenancy, because if you're hosting a service, it's probably going to be available for many, many people, not just one person. And again, if we think about the threat model for this, or like how do you protect this? Like how do you protect a web app or a web API? It's exactly the same. A remote or a streamable HTTP-based MCP server is just a hosted API. That's it. Again, that's kind of the as complex as it gets. Now, the data layer. I talked about earlier that JSON-RPC is kind of the common language on this pipe. And they use JSON-RPC for everything. So including things like lifecycle management, capability negotiation, tool interactions, all this stuff is, whether it's STDIO, standard input output, or hosted MCP servers, it's the same JSON-RPC standard. So again, it makes it very easy to both manage, inspect, and evolve. And that the second part is very, very important because as you see here, there's an example of like how the initialization blob looks like. But think of it like in the future, there might be more capabilities, more features, more requirements for these servers. And JSON-RPC is just the perfect way to encapsulate a lot of this complexity and evolve it with time. Now, also, MCP supports a number of primitives that we're going to get into just in a little bit. And also, it does support asynchronous processing. So if you have applications that, for example, you are interacting with Claude Desktop or VS Code, and you're asking it to process some data somewhere, and you need to wait for the data on the remote side to complete. MCP provides built-in capabilities for those processes, for those servers to basically report the progress back, which, again, can be helpful for long-running operations. The application layer is as simple as it gets, and that is because clients that you build for MCP know how to talk MCP. The servers know how to talk MCP because we have all the SDKs for this. And the APIs or applications that connect to MCP servers are completely oblivious to any of the MCP complexity. Or I don't want to say it's complexity, it's not that complex really, but if you're building something on top of MCP that connects to downstream APIs, whether it's your own API for your internal enterprises or some applications, like those applications need to know nothing about MCP or how to actually plug in with it because the server is the one that's going to be handled that has changed. We're truly living up to the context of good architecture is invisible architecture. You do not want to expose a lot of these capabilities to applications that are not really interested in building anything on top of another custom protocol. Because if you're somebody that, I could bring up Blender because it's such an exceptional use case for it. But if you're Blender, your job is building an application that does 3D modeling. You're not really interested in like, well, how do I expose this to LLMs? Like, it doesn't matter because it's not your job, but the MCP servers will do that for you. Now, let's talk about primitives. I kind of alluded to this a little bit, and that the MCP protocol itself has a number of, I want to say like built-in tools and components that can be used to interact between clients and servers. So, in my opinion, this is again personal take, is primitives is what actually makes the protocol useful. Because we talked about the JSON-RPC and any of the JSON responses, you don't want to craft it by hand. Nobody has time for that. Nobody has time for actually manually managing all the stuff. So for this, again, the folks at Anthropic, when they came up with MCP, they kind of built this concept of, we're going to encapsulate some of these into reusable chunks. They're like the Lego bricks that you can use depending on what exactly you're trying to do. And they're built into the protocol. They're standard in the protocol. And that means that any application, any server that is interacting with it, any client, they all support these. So let's dig into the actual primitives. Number one, tools. Tools is functions. That's all it is. That's, if you've ever invoked a function in Python or C#, that's all it is. A tool is essentially a server saying you can call this function to do something that I allow you to do. So if you have an MCP server for Figma, it can be a function that says, give me the mock. It can be a function that says, create a new FigJam board. If you have an MCP server for a database, it's query database, insert record. It can be anything. It's completely managed by the server. So it can do a lot of things here, and it can do actually an unlimited number of things. Like a tool can do anything the server developer wants. This is exactly where a lot of the AI interop and AI kind of logic meets the business case and the scenarios that you want to accomplish. This is a super, super powerful thing. And when people think about MCP, most of them think about tools. The other one is resources. So again, baked into the protocol is this concept of resources, and that is the ability of the server to essentially expose a number of, think of them as quasi-REST API endpoints, but they're not really REST. So if the LLM wants to get data from a database, or wants to get data from some file, or maybe it wants to get data from documentation that somehow is baked in within itself, it can use standard URI schemas to address those. And there again, if you're squinting just right at this, it's like, well, it's kind of like REST API, but not quite. The other one is prompts. Prompts is similar to tools, but it's actually user controlled. And the difference is a little bit subtle, and I would highly recommend afterwards to actually go and look up on blog.modelcontextprotocol.io. There's a blog from another core maintainer, Ina Harper, who wrote about some of this stuff. And the prompt concept is essentially like the quasi-tool. So think about it like the tool is what's being invoked by the LLM. When you say, you go into GitHub Copilot and say, query the database and find me all the records with the name Dan in the past 6 months. The LLM has to go into the tool and then, or use one of the tools to go and query the database. So it's LLM controlled. With prompts, I, the user, can actually say /command because I use the / sign, and then give me the data, or create me a recipe, or go and create a mock based on kind of the server context that exists. Again, it's kind of the tool by user control. There's also the concept of roots. Roots is interesting because it defines the boundaries where the MCP server can actually operate. So when you connect an MCP server for, let's say, reviewing your code base or creating tests, it is possible for the clients to actually say, like, this server can only operate in this particular workspace and the boundaries of this particular file system. Again, super helpful to manage this control. It's not a security boundary. Do keep that in mind. Like, people mistake this and think that, like, oh, this means that if my MCP server can only access files in my home folder, that means it can never break out of this. This is more like an advisory thing. It's not actually enforcing it unless the client does. And a lot of clients don't. So be very careful with that. Sampling is actually also another capability that's somewhat underappreciated, but it's the ability to request completions based on server input. So you effectively allow to delegate some work from the LLM running on the client that's sourced from the server. So if I am the server and I want to say, like, well, what about converting something to Markdown? I need before you return data to me, can you convert this to Markdown? So the clients can do that and then send it back to the server, processing it locally within the context of the LLM that you're using. The one that got launched recently, and this one is I want to say that it's not controversial, but people kind of ask a lot of questions about it. It's called elicitations. And think of elicitations as a way for the server, for the MCP server, to go back to the client that is hosting the LLM and ask for very specific information. For example, if you have an MCP server that's, I don't know, responsible for managing databases, you might ask, like, okay, well, what database do I need to manage? What's the URL for specific data store? And in this case, I don't need to actually go and ask the LLM and hope that the user types in the right URL directly into the box. I can just send an elicitation that is actually JSON schema bound. So I can say, I expect the user to return a URL and a URL only. And in this case, what's going to happen is that the client is going to render a dialog box. Again, that's as complex as it gets. It's basically a way for the client to provide a modality to ask for user input. That's what elicitation is. Important caveat here. These are not meant to be used to request secret information or private information, because the elicitations will be passed through the LLM. Like some of the stuff, like I mentioned here, the client returns concrete input to server without passing through the LLM, but the context itself is available. So you have to be careful not to use this to pass API keys or credentials or tokens or anything like that. We are working on that though. Let's talk a little bit about kind of the life cycle, because we've talked about the primitives. There is some important things that you should know about in terms of lifecycle management. Every server and every client will always negotiate the list of capabilities they support. We talked about the primitives, like elicitation was a new one. It just launched. It is possible that some clients do not actually support it yet. So when MCP clients connect to MCP servers, they always negotiate the capabilities so that client knows what is the server actually capable of and what is the client capable of. Also, I mentioned at the very beginning that MCP is bound to what's known as a specification. Specifications evolve. Specifications have multiple versions. That means that if I have a client that's been built with a new version of the spec, but my server has not yet supported it, I somehow need to negotiate that. So all this is baked into the logic of the initialization process. So you can actually negotiate the versions as well. Not only capabilities, but say, I support this version of the spec. Do you support it as well? Very important. And shutdown, this is again, from a lifecycle perspective, this is the most boring part, but like it's whatever is used for whatever's used for a transport layer. It literally is, if it's a local application, just like terminating a local app. If it's a remote server, just terminating the HTTP connection. That's kind of it. Now let's talk about the spicier topic, security. Does anybody have any idea of how people perceive MCP security? No? What security? Okay. I heard like the S in MCP stands for security. Yeah? Yeah? It's about this, right? That's what MCP security looks like. I actually disagree. I don't think it's that bad. So again, biased. I'm a contributor focused on security and auth. But I do want to remind about what I just mentioned right before when we were just starting this out. Always remember the execution context. Local MCP servers are local binaries running on your box. That means they have access to everything on your box in the context of the user that is running there. Every single time. I see people running some scary MCP servers, and again, no shade on any specific MCP server developer, but like if you ask me, would I download an MCP server that's gonna read all my messages from some random GitHub repo that I've never seen before? Like the answer is no. Just like I wouldn't run any local binary that I do not trust and know about. So be careful what you install. With local MCP servers, people always ask like, well, how do I do auth? How do you do auth in any local app? That's exactly how you do it here. You can use any library. For example, if you're using GitHub, you can use OctaKit, you're using Enter ID, you can use MCell, you can use any of the possible libraries to connect to downstream APIs. Remote MCP servers are just hosted APIs. Be careful what you install the same way, because they will ask you for credentials. if they ask you for credentials and you log in to an MCP server that you do not know about, do not trust, and don't know the vendor, you're risking your credentials. That being said, remote MCP servers are using authentication and authorization via standard OAuth. So as OAuth has existed for some time, it's already in MCP servers, it's embedded there. It's per spec. We actually just updated the spec in this June revision. And you have to be careful again with servers you install because there's different attack vectors that exist in introducing vulnerabilities to your companies, into your environment by proxy of things like phishing and confused deputy attacks. So it's, again, just like any hosted APIs, don't log in where you don't know. Okay, so local servers. If local servers, as I mentioned, they're local binaries that run on your box, there's no client to server authorization today. So any client can run any server, and any server can connect to any client. So there's no client identity or server identity whatsoever. You basically say like, hey client, run this .NET command to run my MCP server. And it will run it. And it will connect to it because it's just a process. Within the actual MCP server, the local MCP server that runs on your box, developers can embed any components that do anything, any library, anything to get user credentials, anything to process data, anything to transform data. You have basically complete free reign on what you can do. That also means the local servers can talk to APIs in whichever way they see fit. So if you're using REST or SOAP or whatever else, it just would work, just like any other local application. Remote servers, though, can, and I have a caveat here that says, but not necessarily support client-to-server authorization. Folks kind of snap to OAuth. They know it exists. They start implementing it, but not every single server is actually supporting it. And for a variety of reasons. Some servers just don't require authorization, and that's fine. If they don't access private information, you don't need authorization. For those that do support it, though, they snap per spec to what's known as OAuth 2.1, and that is OAuth 2.0 without the bad parts. That's how I would describe it. There's a misconception here, though. When people think about protecting remote MCP servers and putting that authorization layer on top, they think like, oh, I can only use OAuth. That's the only thing I can do. And that's not really true, because what the spec says is that you have to use OAuth 2.1 for this to be able to interop with any number of other MCP clients and MCP servers, but it is not the upper bound. So if you're deploying MCP servers inside your company that need to use certificate auth, you can absolutely do that. If you're deploying MCP servers inside your company that use client secrets, which you absolutely should not be doing in 2025, but if you do, that is possible. Now, acronyms that you should absolutely know about. I'll give you a second to kind of read through these, but all of these concepts make their way into MCP in one way or another. If you're not an identity expert, that's okay. If you do not care about ever seeing these acronyms ever again in your life after this presentation, that's okay too. And we'll get to them in a second. So this is the most important question that people ask us all the time. How does auth actually work? So we had two specifications. When MCP first came out, one of the things that the folks at Anthropic did is like they kind of bundled some concepts together. And they said, well, if you are building an MCP server, surely you are going to be an identity expert as well, and you're going to build your authorization server. That means that you need to handle things like minting tokens. Like, how many of you know what a jot is? Okay, a few people. How many people are comfortable enough to generate their own jots? Okay, but less people, a few. That's okay. How many people here are confident enough that say that if you generate your jots, if you do this, you're secure from nation-state actors and you know how to protect them and gate the token access and cache it properly? Nobody. Okay. And that's exactly why this was a problem. This is where we talked to Anthropic and said, hey, this is not going to work. You can't ask people to go and mint their own tokens and maintain their lifecycle and be confident enough that what they're going to build is actually going to withstand a lot of the security threats that we see today, because it's just problematic in a million ways. You have to be an OAuth and security expert to actually build that at scale. So we worked with them to basically say, look, what if instead we do a clean separation between what the MCP server does and the authorization server does? And what the responsibility is in this case, like you as a developer of an MCP server that wants to expose the API or some applications that run on the server, don't actually need to worry about implementing all the security craft. So we did. We pushed a new spec that just got released in June, and all it did is essentially said that, look, if you're using any of the identity providers that are completely off the shelf, you can. The MCP server is going to advertise what identity provider it's using, what authorization server it's using, and then all the responsibility for token handling is out of your hands. It's just gone. And the client is going to be the one that handles the token storage and everything else, and the server just focuses on the compute. So for you, as a developer, somebody that actually is building MCP server, that means that you're not implementing any of the authorization server logic. None. Which is a huge, huge win for basically everyone in the security space. Also, any MCP server, specifically we're talking about remote MCP server, because again, for local, this doesn't matter. For local, you just use libraries to auth with things. There's no client to server auth. For remote though, you're going to be using capabilities that allow the server to tell the client, hey, I'm using Entra ID, I'm using Okta, I'm using Auth0. Like all these components are just baked in. And it's, again, standard OAuth. You don't have to worry about any custom work that's for MCPs because it's just OAuth. Now, there's also an important caveat here is that the client is responsible for doing the end-to-end kind of the token exchange dance. Like when you go to log in, the client is going to be the one doing a lot of the heavy lifting. You as a server developer, if you're providing any APIs, you just don't need to worry about any of this stuff. The client is going to do it for you. All you need to do, though, in the server is make sure that the tokens that you do get from the client are destined for your server. Remember the concept of like web APIs? It's exactly the same threat model. Remember, it's like you have to do things like token validation on the server, just like you would for any hosted API. And all of this is just a longer story to tell about the fact that you have minimal implementation work. As a server developer, your goal is to focus on what your server does best. So what does the actual flow look like? MCP client and MCP server, two core pieces. One, when the MCP client requests data from the MCP server for the very first time, the MCP server is going to respond back with a standard 401 and say, I have no idea who you are. Actually, I have no idea who's the user behind the scenes. Can you please go to this document, and we refer to it as the PRM, the Protected Resource Metadata Document. That PRM document is going to contain information about what the server is using to protect itself. So the server is going to say, go here and fetch this document and build an understanding of what exactly you need to do to authorize the user. And the client will say, great, let me go get the PRM. And the PRM is just a JSON blob. It's a hosted JSON blob that says, yep, I am resource at example.com. By the way, this should be the server URL. Here's the authorization service that I'm using. Again, it could be Entra, it can be Okta, it can be Auth0, doesn't matter. It's completely vendor agnostic. Oh, and by the way, here's the ways I support bearer tokens. Like whether you want to embed it into the header, the body, some of the scopes. And maybe if you want to learn more, I have some pointers to documentation. So go there. The client is going to take that information, and then talk directly to the authorization server. You as a server developer will never even touch that piece because at this point, you're just going to be looking and say, oh, cool. You know, I'll go talk to the auth server to do the token exchange, and you'll get through the client is going to go through the dance of authorization code flow, hitting up the authorize endpoint and doing all the discovery. And then the auth server is going to return the tokens and say, client, hey, use these tokens to get to the server. And then the client is going to take them and use them with the server. That's it. That's, as again, kind of like how the flow goes. You as the MCP server developer will need to worry about making sure that you're validating tokens. This also means that you can use any off-the-shelf providers. This is going to be controversial because I'm putting a lot of logos here. None of these companies have endorsed this talk. This is just me talking about generically about model context protocol authorization. But the more I talk to developers that use MCP, like any providers, off-the-shelf providers, you can use them with your MCP servers. And the one thing when I always talk about this, somebody will inexplicably say, like, I'll just bake in the token directly into my configuration file. And I say, oh dear God, no. Do not embed the tokens in your configuration file. Do not embed tokens in your server in any capacity. Do not send them to the client. Do not send them to the LLM. Very, very important to make sure that you are not providing these credentials in an insecure way, because they will get stolen and they will get abused. So, what are some of the best practices you should follow? Do not rely on writing tokens or API keys directly into your configuration files unless you absolutely have to. And there are some servers that require API keys, and that's fine. But when possible, do use OAuth. Number 2, token pass-through. This is the thing that is the most confusing for a lot of folks, and I always love explaining it. Let's say you're building a MCP server that wants to do something with, let's say, Outlook. It's going to manage your email. And usually when that scenario comes up, people say, oh, good. I can just log in with Entra ID, request the scopes for email, and just pass the token to the server. And the server can just access my mailbox. Like, that's easy. That's not right. And why is it not right? Because the token that you get is not issued to your server. It might be issued to Outlook. You cannot use that token and send it to the server, because the gate here is, can the user access your server, not can the user access Outlook. Once the user can access your server, you can, out of band, solicit requirements to say, oh, by the way, you also need to connect to Outlook, and I'm going to store that token server side. And that's great, and that works. But token pass-through is never okay. You're going to end up in a lot of trouble security-wise if you do that. For servers, they use static client IDs, and this is primarily gated in the fact that one of the things that I alluded to in the kind of the acronym slide before was something known as the dynamic client registration. This is actually a somewhat new concept that got introduced with, it's not introduced by MCP, but it's made popular by MCP. And DCR, dynamic client registration, basically means that in the world where we don't know how many MCP clients exist, we don't know how many MCP servers are out there, it'd be untenable. Like if you've worked in any of your companies and you know you have an Entra ID tenant, and you have to go and register an app, go and register the redirect URI, go and validate that app and give it permissions and your tenant and all these things, that's just not going to scale in the world of MCP, because there's unlimited number of MCP clients, unlimited number of MCP servers. How do you manage all of this? So this is where DCR, dynamic client registration, comes to the rescue and saying, you know what? You can just register them dynamically. As a new client comes online, like say Claude Desktop, and you connect an MCP server, and the MCP server says, I'm actually protected by Entra ID. What the client typically would do is hit up what's known as a register endpoint and say, oh, let me just register myself with Entra ID. Let me just give Entra ID the redirect URIs that I need so that you can go through this dance. The problem is Entra ID doesn't yet support dynamic client registration. So what a lot of folks are doing is they shift that responsibility to the server and say, oh, well, my server is going to be the one doing these things, and then my server is going to bake in a static client ID that's associated with the server, and I'm just going to talk to Entra ID downstream myself. And what happens then is you will end up with a potentially dangerous situation, which is confused deputy, and where you need to make sure that the client always, the user always consents to the client being able to talk to the server and get tokens at Entra ID. So this is, again, a very specific case that's documented. I'll probably point you to documentation because it explains it better than I can do in 15 minutes. Do not use session IDs for authorization. That's, again, piggybacking off of the API conventions that existed before. when MCP servers interact with MCP clients, they can bind things to sessions. They say, I'm part of the sessions, and fetch a GUID. That GUID is only indicative of the session. It actually doesn't mean anything in terms of authorization. So you should never use that to make decisions around auth. All the typical vectors in terms of like the login flows that existed for web apps, like all of the CSRF tokens that you do against a lot of the existing session vulnerabilities, all the stuff is still applicable today. There was a conversation at Black Hat yesterday at the conference where they talk about some of the vulnerabilities with OAuth and MCP, and like all of these things keep resurfacing because people think that this is something brand new, but again, it's not. And do not, under any circumstances, try to re-implement authorization servers. Like I've seen people kind of take the path of like, oh, I'll just go and do like token minting myself, and I'll do refresh token and maintain that. Like, just use something that's off the shelf. Like something off the shelf is always going to be better than something that you can implement yourself without you being a security expert. If you are a security expert, I have enormous respect for you. Please help us secure this more. If you're not, do not re-implement yourself. Now, before I go to some of the community stuff, I will pause here and we'll see if you have any questions while I refresh this. Let's see, folks, any questions? Okay, gentleman in the front.
How are local MCP servers packaged and distributed?
How are local MCP servers packaged and distributed? Great question. There's a variety of ways that can be done and that we see people do. There's no single uniform way of doing this that is globally applicable to any client, I'd say. So today, I can do it through GitHub. I can do it through my own website. I can do it through NPM. People put packages on NPM. People put packages on like the Python distributions. Like it can be literally any way you want. Anthropic has actually came up with a way for desktop. They call it DXP for desktop packaging, but it's specific to some of their distributions, and not a lot of other clients actually snap to it. So for local MCP servers, distribution is basically the Wild West. Whichever way you want. You can email people. That's kind of the state of the world today. That being said, one of the things that we are working on addressing is what's known as the registry. And that is the biggest problem that exists today in a lot of the world of MCP servers is basically like, well, how do I actually allow people to discover MCP servers that exist? And the discovery today is very manual. Like you have to know that to go to GitHub. You have to know to go to some website somewhere, and there's like third-party listicles that tell you what the servers are. We are actually formalizing that process. So there's going to be an official MCP registry API, and there's going to be registries like recently we launched, like if you go to mcp.azure.com, you can see some of that work, to get basically a unified discoverability layer for all MCP servers, remote and local. All right, let's see for more questions. Okay, another question, gentleman in front.
So as far as I understand, like the client is responsible for starting the local MCP server, correct?
Correct, yeah.
And like what happens if client dies?
If client dies, the process can either live or not. Again, it depends on how the client actually handles it. Like in this case, if there is no graceful termination on the client, and then the process is essentially orphaned, it's just going to stay running, right? Because again, it's just another application running on the box. All right. Any other questions? Surely I did not explain everything. Okay, yes, gentleman in front.
Talk about like if you're using a internal language model, how you can include the connection to like even say a local server in that language model.
Local server in a language model. So for those scenarios, you actually do need to have clients that support integration with MCP in the first place, right? So if you're using something like that is built by yourself, you have to basically bake that in yourself. If you're using a client that does support this out of the box, that would work. You also need to have an LLM model that actually supports things like function calling. So I would say look in a lot of this data, by the way, is available. So there's no universal answer for every single model is going to be able to do this. So for example, one of the things I've been running into recently, I was trying to use Olama with some of this stuff, and it was a bit more complex than with remote. So there's a bit more legwork involved, but it is, I think a lot of the folks right now are looking specifically because a lot of the models become very powerful locally as well. So the MCP world starts kind of immersing itself into that space as well, but maybe it's not as mature yet.
So would you, if you are the client and you're starting the initial session, right? You potentially would have to every time say, here's my MCP server, get protocol for it. Every single, beginning of every single chat, right?
Yes, you basically go through the initialization dance, right? And this is what the clients do. And then there's, of course, limitations, folks that might have connected a lot of MCP servers. There's 128 tools, so the client needs to be able to filter through those. So you run into a lot of these scenarios. So a lot of this burden actually sits with the client being able to do a lot of this dance before it even hits the model, right?
Okay, yeah. So unless you actually build out to the some of the initial prompt staging, you would have to say I want to do this, but look at this reference first, and then.
Right. Yeah. See, there's some more legwork involved for sure. Okay. So we'll get to more questions. I should mention also that I did not call out the fact that there's actually a lot of tools and SDKs that can help you. So first of all, SDKs. We have a bunch of open source SDKs for almost every language imaginable. And I say Kotlin here, and also it's important to call out, there's also a specific Java SDK. So do not get distracted by Kotlin. But whether you're a C# developer, Python developer, Rust or Swift, if you're to one of those niches as well, you have SDKs for this. You can actually build both MCP clients and servers with those. And there's a very concerted effort to make sure that those SDKs are supporting a lot of these capabilities out of the box, all the new stuff that gets into the spec, they're spec compliant from day one. The other tool that I should mention that if you're exploring MCP, that is a must have, it's called the MCP Inspector. It's a free tool that is available on NPM, so you'll actually have to install Node.js, fortunately or unfortunately, although I almost guarantee it's already installed in your box in some capacity, but you can actually run it to test any MCP service. It's basically a mock client that does everything with MCP. It is spec compliant. We're working very closely with the developers there to make sure that it's out of the box, allowing you to test the newest functionality that makes it MCP. Does anybody else wants to guess what is the other tool that you can test MCP with that is probably the best one on the market? Yes. Postman. Okay, maybe. That's actually a solid guess, Postman. What else? Maybe. But does the logo ring a bell to anyone? Yeah? This is actually the best tool. And because the folks that are building VS Code are very actively engaged in making sure that a lot of the spec capabilities are supported again from day one. When we had, when Auth landed with a new specification just a few months back, again, ages in the modern AI era, VS Code was actually the first one to implement the full spec. So we were just hammering at a lot of the URLs, and we knew when things were broken because they did not work with VS Code. Okay, so all the stuff out of the way, community. So this is a very, very important part. It's not necessarily technical here, but I do want to mention that community is very important. And one, the spec and SDKs are all open source. Literally all of it is in the open. There's nothing secret about MCP. All contributions, whether it's to SDKs, whether it's to the spec, are done on GitHub. There's a Model Context Protocol organization on GitHub that you can go to. You can actually contribute yourself. We have a pretty good set of issues and pull requests that already exist, and you can inspire yourself from those and then contribute as well. That's actually what I want to pitch every one of you here, is that you, all of you, can contribute to MCP if you want to. It's open. There's a Discord that exists for basically all aspiring contributors, all new contributors, and established contributors like myself. Again, 6 months or 8 months, right? It's established. So there's also a brand new governance process that MCP has established fairly recently in terms of how to structure new proposals and how to actually get people's suggestions and feedback and spec changes into the pipeline. And all of it is called a SEP, a spec enhancement proposal. So if you are using MCP, and for example, like in the scenario, we're using local LLMs, and if things don't work, create a SEP. Don't just create a SEP. That's like anybody can do this. There's no requirement for you to be somebody that is like an expert LLM crafter or anything like that. Like anybody can say, look, this doesn't work. And for my scenario, I'll go and write up what needs to happen. And then the core maintainers, the maintainers are going to pick that up, review it, and help you merge it. Some closing thoughts. As I mentioned, get involved. I honestly could not ask for more other than go to modelcontextprotocol.io, explore this, go to the GitHub repo, go to the blog, and just learn more and see where things do not work and where things can get better. The protocol is very, very young. Again, it's like not even a year old. Like think about it. Like it's months old. I'm sure there's things that you've experimented with. You're like, this just doesn't work. It doesn't fit my scenario. So go there, try it out. If you have questions and you're like, I have no idea if this is actually worth, I don't know how to submit a SEP. I don't know idea how to go and tackle this particular problem with security. Talk to me. I'm available. Like you can reach out on my website. I have my email there. You can go to LinkedIn. You can go to Blue Sky. Like wherever you are, just talk to me. My core priority is to get people involved with this and making sure that MCP serves what you are trying to get done with your AIs, with your clients, whether it's VS Code, whether it's Claude Desktop, or it's Codex from OpenAI, like it doesn't matter. I'm here to help. So do reach out. Thank you again for your attention on this beautiful morning and taking your coffee with me. And if folks have any questions, I'm happy to answer them.